right, guys. So for Unit 3, we're going to start with some vocabulary. We're just going to start with rate of change right now, and then we'll do a problem with rate of change from your textbook. I'll give you the other definition, and we'll do some notes, and then that's it. So Unit 3 vocab, we're talking about slope and rate of change today. So let's define rate of change. Rate of change shows the relationship between two changing quantities. Okay, so rate of change shows the relationship between two changing quantities. For the example, I'm just going to give you the kind of the definition of rate of change, but in terms of a ratio. So our rate of change equals change in the dependent variable over change in the independent variable. And I'm going to write it small so it will fit. Change in dependent variable over change in independent. Okay. Okay, so let's look at rate of change when information is given to you from a table. We are on page 168. We're looking at number 2. So we're skipping number 1 and we're just looking at number 2. Okay, so in this table, it is giving me the descent of an airplane over a certain amount of time. So when we're looking at rate of change from a table, we need to look at rate of change from each interval that is given on the table, because the question is going to be, is the rate of change constant? So let's look at the table and see what information is given to us, and then we will use that information to determine if our rate of change is constant. So let's look at the left side first, time. That's our independent variable. In time, to get from 0 to 2, what do we do? Add 2. And then the next interval of time in minutes goes from 2 minutes to 5 minutes. So how much time has passed there? 3. So plus 3. And then from 5 minutes to 12 minutes, how much time has passed? 7. Okay. Now, going from 2 to 3 to 7, it at first doesn't seem like our rate of change is constant, but it could be if we look at our ratios and everything ends up being the same. So let's look at how much each change in elevation occurs between intervals. So from 30,000 going down to 29,000 feet, how much did we change? 1,000. Negative 1,000. So what about 29,000 to 27,500? Negative 1,500. And then from 27,500 to 24,000? Negative 3,500. Okay. So then how can we determine if our rate of change is constant? We look at each average rate of change between each line in the table. So we're going to end up doing this 3 times. So the first one is going to be from 0 to 2 and from 30,000 to 29,000. Now, our rate of change is dependent variable over independent variable, so we're going to put the negative 1,000 on top to start. So we're going to do the first interval first, so that's negative 1,000 over positive 2. And that reduces, right? What does that reduce down to? Negative 500 over 1. So you don't have to put the over 1, it's just negative 500. So let's do the second interval. Our dependent variable we already determined is changing by negative 1,500. And our independent variable is changing by what? 3. What does negative 1,500 over 3 reduce to? Good, negative 500. So it kind of appears that our rate of change is constant, right? Because we're looking at the unit rate of change, but let's do the last one just to make sure. The dependent variable was changing by negative 3,500, and the independent variable changed by what? By 7. So what does that reduce to? Negative 500. So was our rate of change constant? Yeah, just because the table gave us information at not constant intervals or at consecutive intervals, then that doesn't mean that our unit rate of change is not constant. So our unit rate of change is constant. So we would say rate of change is constant. And then we want to know what it is. So because we were looking at rates of change over non-consecutive intervals, consecutive meaning like 1, 2, 3, 4, 5 in order, we would call that the average rate of change. Is negative 500. And what were we looking at? What are our units?
Feet per minute.
Feet per minute. So feet over minutes. Because we were putting the change in feet on top over the change in minutes. So your homework is going to ask you that, basically. But it will give you the specific intervals to find. So you're not going to have to do every single one for every single line on the graph or on the table. So that's our rate of change. So then when we're taking this rate of change from a table and we are looking at it on a graph and as a linear function, we call that unit rate of change the slope. So that is your next definition in your notebook. Okay, so now taking rate of change from just looking at a table or looking at a situation, and we're going to talk about rate of change in terms of a graph or a linear function, and that is what is called the slope. Slope is the rate of change specifically of a line. Okay, so slope is the rate of change of a line. A line can be either on a graph or on as a linear function. And the example for that, slope equals, since we're talking about the dependent variable over the independent variable, which axis is my dependent variable on, X or Y? Y. So it's going to be, and Y goes vertical. So we call that vertical change over my independent variable, which is on the x-axis, so that is horizontal change. Okay, so in our notebooks, we're going to be talking about slope, so that's why the concept is in the middle. Here I'm going to give you a more detailed definition of slope. I'm going to give you 2 different formulas for slope, and then in the bottom we're going to do 2 examples, one finding the slope just from the graph, and one finding the slope just from 2 points, okay? So that's kind of the plan. So in your notebook, we should be on page 36, date, title, and then here we go. So the official definition, detailed definition of slope, slope is a ratio. Another word for ratio is what? Fraction. Slope is the ratio. It says the. Slope is the ratio. And I'm boxing ratio to remind you that it's it's a fraction. So slope is the ratio of vertical change and vertical is the change in the y's, so up and down. We also call that the rise. Rise, meaning up and down, because you rise. Yep. 2, the horizontal change. Horizontal is left to right, and we also call that the run. So a lot of you guys are putting that together now. One formula of slope that we can use is slope equals rise over run. This is a very unofficial formula. Using just this definition of rise over run, we're going to do an example of finding the slope from the graph. So here's the graph you're going to use. Do the best that you can to sketch it in your notes. And to have us start, I'm going to write it out, slope equals rise over run. You won't have to do this every single time, but for this time I want you to. To find the slope from a graph, basically all we're going to do is count the rise and count the run, and then write it as a ratio. So before we can even start, we need to identify what those points are. I always start at the bottom point. What are the coordinates of that point?
2, 1.
Nope, wrong. -2, -1. And the coordinates of the top point?
1, 1.
1, 1. Okay, so you're going to need to find 2 points on your graph. And then I always do rise first. And we actually have 2 options. We can choose to count the rise from the top point and go down, or we can count the rise from the bottom point and go up. Doesn't matter which way we go. No, because if you are going from the top point down, you have to make sure that your rise is going negative. But then when you go over to the other point, it will also be negative, so it will cancel out. From this one, I always like to go from the bottom and go up. So if I'm going from -1 to +1, what is my rise? 3, +3. So let's plug that in. No, it's not. It's from -1 to +1?
2.
It's 2. Who said 3? Okay, we go up 1, 2. So it's not 3. It's embarrassing. Okay.
You're the teacher here.
So
You go for it.
So, now that I counted my rise, I need to count my run. My run goes from -2 to +1, so that's 1, 2, 3 spaces. So that one is 3. So my slope is 2 over 3. That's it. Okay. If I had gone down, that would have been -2, but going to the left is also negative, right? So going to the left would have been -3, so that would have reduced to still +2 over 3. Okay? So going up or going right is positive, going down or going left is negative. Okay? So essentially what we did here is we found the distance between the y values, because guys, what's 1 minus -1? 1 minus -1? 2. And what's 1 minus -2? 3. So we're just finding the distance between the points. So the other formula for slope. The variable that we use for slope is m. Please don't ask me why, it just is. So it's m. Probably because s is taken for speed. I don't know. Here's your slope. So, slope formula. Now, if we are counting the vertical change, the rise, is that the y values or the x values? The rise. Y values. So we say y2 minus y1. These are not exponents. These are subscripts. which are, like, it identifies what point it's coming from. So y2 means it's the y coordinate from the second point. y1 means it's the y coordinate from the first point. Over my run, which is my x value, so it's going to be x2 minus x1. That's your slope formula.
I totally remember this now.
So you can use this slope formula to calculate the slope without having to graph it at all. So we're going to calculate the slope between 2 points, -1, 0, and 3, -2. To start, I'm going to put m equals y2 minus y1 over x2 minus x1. Like I said, guys, you don't have to do that every single time, but at least in the example, I want you to, so that way you know where the numbers are coming from. Okay, so you can actually choose which point is the first point and which point is the second point. It does not matter. But I am going to then have you label at the x1, y1, and the x2, y2, so that way you can keep track of everything. So do you guys want to make -1, 0.1, or do you want to make 3, -2.1?
3, -2.
3, -2 is going to be the first point? Okay, so if 3, -2 is our first point, let's label it. 3 is going to be our x1, which makes -2 our y1. You can choose whichever. If you chose -1, 0 as your first point, your answer is still going to come out the same. So that makes -1 x2, and that makes 0 y2. Okay? So the 1s mean that they are coming from the first point. The 2s mean that they're coming from the second point. So let's plug everything that we know in. So what is our y2? 0. So that's going to be 0 minus. y1 is -2. Make sure you put it in parentheses, because it's minus a negative. And then x2 is what? -1, and x1 is 3. Now, I had to put the first or the second points, the coordinates from point 2 in first, and then I subtracted the coordinates from point 1. Does the order matter? Like, could I have done y2 minus y1 over x1 minus x2?
No.
Does subtraction, does order matter? Yes. So when I am subtracting, if I subtract y2 minus y1, I have to do x2 minus x1. Does that make sense? So that you're subtracting in the same order. And then we simplify. So, what is 0 minus -2? When I'm subtracting a negative, what happens? Everything becomes positive. So what's 0 plus 2? 2. And then -1 minus 3 gives me what? -4. Can I reduce that? Yes. And then one thing I want you guys to start getting used to, I only have one negative, right?
Yep.
A positive divided by a negative gives me a
Negative.
So I can actually put the negative on the outside of the fraction, because that just means the whole thing is negative. And 2 over 4 reduces to 1/2. -1/2. And that's the slope formula. So, on page 171 is a nice little summary of kind of everything. So let's talk about these two first. Look at the first graph that's on here. Is that an increasing or a decreasing linear function? Increasing. So what would you expect the slope of an increasing linear function to be? Positive or negative? Positive, right? So when we are going to start graphing these lines, which we're going to do tomorrow, if you have a positive slope, your line should come out to be increasing. So it's kind of like a way for you to double check your answer. What if the line is decreasing? What kind of slope will it have? Negative. And then we have two special cases. We have vertical lines and we have horizontal lines. So I want to go over these very, very quickly. First of all, let's do the horizontal line. I'm going to just pick 2 points on my horizontal line, -1, 2, and +1, 2. So pick those 2 points really quick. Going from -1, 2 to +1, 2, what's my rise? How far up and down do I go? 0, because it's flat, right? But what's my run? 1, 2. Okay, 0 divided by anything is what? 0. So if you have a horizontal line, a flat line, your slope is 0. Does that make sense? Okay. No, so if you see a horizontal line, you can automatically, okay, and then, so let's look at what happens with a vertical line. Okay, so a vertical line, I'm going to put a point at 2, 1, and at 2, -1. So let's start from the bottom and go up. What's my rise? 2. Now, what's my run? Okay, question. 0 times what is going to give me 2? 0 times 0 is 0. 0 times 2 is also 0. So nothing. So we call this undefined. Because you're never allowed to divide by 0, right?
Why not? It's impossible.
Because it violates the rules of math. This also should make sense because, think about it, is a vertical line a function? No. So can a non-function have a slope? No. So if you ever see a horizontal line or a vertical lines are automatically undefined. Horizontal lines are automatically 0 slope. Those are the special cases. Okay? So the left-hand side we will do tomorrow as a warm-up really quick. So we will do the left-hand side tomorrow. So let me pass out your homework log and your handouts for today.